Hello everyone. Today we're going to go ahead and learn about how to evaluate inverse trig functions. Okay. So the first thing I want you to go ahead and do is start with this warm up. I want you to find out what are the lengths associated with a 30, 60, and 90 triangle. So what are the lengths, the opposite here, the hypotenuse and the legs of this right triangle. Do this for both the 30, 60, 90 and the 45, 45, 90. So go ahead and pause the video. Okay, so from here, we're gonna go ahead and see that these are from our notes that we took in Unit 4, but just to help us recall, the length that comes from the angle 30, also known as pi over 6, that length projects, that angle projects a length of 1. Okay, keep in mind the smallest angle goes ahead and produces the smallest length. For 60 degrees, okay, 60 goes ahead and creates the length of square root of 3. And we have a 90 right here. This right here creates a 2. For the 45, 45, 90, we can see that the length that comes from the for the 45 is a 1. The 45 here also creates a 1. And the 90, we can use that with the Pythagorean theorem. That gives us a square root of 2. Okay. Now, for 60, that right there, in radians, that's pi over 3. Okay, just to help us fill this in, 90 is pi over 2. 45 degrees, that is pi over 4. And we just saw that 90 was pi over 2. So hopefully this was a nice little warm-up of our 30, 60, 90 and a good review from what we haven't seen in a while. Okay, today's notes are here, so make sure you label your table of contents. And let's continue. Okay, looking at a week at a glance, we have that today's notes 5.1 will be due today at 5 p.m. Okay, and tomorrow we do have a little quiz, 3-question quiz, and a review. Okay, so super exciting. Okay, we're gonna go ahead and learn about these inverse trig evaluations. Okay, so pretty much let's go ahead and stamp the idea of what it is to have the inverse trig. What is it telling us? Where does it come from? Well, in Unit 4, we learned this. If I give you a trig function, let's say sine, cosine, tangent, any of the 6, and I evaluated at an angle, whether it is degrees or radians, you guys gave me a ratio. Now, here, this was Unit 4, here in Unit 5, we're going to be talking about its inverses, so backwards. If you give me a ratio, I'll tell you an angle that gives me that ratio. So for example, what we saw in Unit 4 is sine of 45, and we evaluated that was square root of 2 over 2. So here in Unit 5, if you give me that ratio and I do the arcsine of it, I'll get 45 degrees, okay? So go ahead and write that down. What you don't have to write down is the unit circle. Hopefully you still have it from our Unit 4 lesson. We dedicated a day just constructing that. But what we're doing essentially is the same thing. If I give you, let's say, 1/2, and I tell you what is the angle that created this, well, that's when the arc inverses come, right? So if I tell you the arc sine of 1/2, you should be able to tell me, hey, that comes from 30 degrees and so forth, okay? Now, something that I continue to see, and it isn't that bad, it isn't that hard to really get right, is this right here, the trig bow time. Keep in mind, guys, this right here, this bow time tells us where to draw our triangles. So ideally, well, the angle will be here in its center. So let me go ahead and use black. The angle will be closest to the origin. And from here, we can see that this is the hypotenuse. This will be my opposite. And the adjacent's always on the x-axis. Okay. Ideally, we can go ahead and do the rest. So if this is my theta, this right here is my hypotenuse. My adjacent's right there on the x-axis, and the opposite's right here. Something that I want you to take a close look is that this opposite is below the x-axis. So in terms of height, this opposite is negative. Okay, I want you to go ahead and try quadrant number 3 and fill in the adjacent, the opposite, and the hypotenuse with its associated lengths, positive or negative lengths. So hopefully you were able to see that the hypotenuse is right here. My adjacent is still on the x-axis, and my opposite's right here. However, this adjacent is to the left of the y-axis, so it has to be negative, and the opposite is below the x-axis, so it also has to be negative. One question that is really asked a lot is a hypotenuse negative because it's also below? Well, keep in mind how we found the hypotenuse. It is found by doing the Pythagorean theorem, and we see that all of these terms are squared. So even if one of them was negative, we were to square them, they become positive. So something you should write is our hypotenuse is always positive. Okay, so we should all be like the hypotenuse because they're always positive, no negativity. Awesome. Okay, something that I also need you to go ahead and write is the following. These right here will go ahead and tell us the restriction of these inverse trig functions. So let me go ahead and get a pen. So by now we went ahead and wrote this yesterday on our notes, but now I'm going to go ahead and give us a visual. So what I'm saying is that the only outputs for the trig functions are these, that no matter where they ask you to evaluate them, we can only find them in this right here, in quadrant 1 and quadrant 4. Let's say right here, quadrant 4, sorry. Okay, so whenever they tell you, hey, go ahead and find the inverse trig of a positive function, it will be in quadrant 1. Find the inverse trig of a negative, it will be in quadrant 4. Okay, now for the range of my arc cosine, if it's positive, will be in quadrant 1. Keep in mind everything is positive in quadrant 1, whether it is sine, arcsine, arc cosine, or arctangent. And for arc cosine, it is negative in quadrant 2. That is different for tangent. Arctangent, it is negative, very similar to arcsine in quadrant 4. Okay, keep in mind you cannot have 90s in arctangent, but you can in arcsine. Okay, so let's go ahead and do some practice problems. I'm going to go ahead and put these on the right hand side of my PowerPoint so you guys can have them as reference. Ideally, that's how I want you guys to do these practice problems, but you have your notes right next to you. Okay, so let's go ahead and begin. I see here I have an arc cosine, right? The little -1 is the same thing as saying arc cosine of this proportion, square root of 3 over 2. So I'm going to go ahead and look at my SOHCAHTOA, and I'm going to see that I'm working with ka, right? I'm working with my adjacent side divided by my hypotenuse. Now, from here, that's going to tell me that, hey, I'm going to go ahead and look at this right here. I'm going to go ahead and be restricted, right? I'm going to be restricted to quadrant 1 and quadrant 2. Okay, in quadrant 1, it will be positive, and in quadrant 2, it will be negative. So I'm going to look at this fraction right here. It is positive, so I'm going to go ahead and draw my triangle. And keep in mind, I have to draw it to the x-axis, meaning it has to follow that little trig bow time. So I'm going to go ahead and do it. I have something like so. And then keep in mind, the theta is always closest to the origin. The origin's right here in the center. Okay, so I have this theta. So I'm going to go ahead and label everything. This length opposite is, this length opposite, the length projected by that angle is my opposite. My adjacent is the one on the x-axis, and my hypotenuse is this radius right here, the longest side. Okay, now what I'm going to go ahead and do is I'm going to go ahead and fill this in. So let me go ahead and see. I have my adjacent side. My adjacent side is a square root of 3. It is positive because it's on the positive side of the x-axis, and my hypotenuse is 2. This right here, guys, we are working inside the unit circle. So therefore, we're going to be able to use our 30, 60, 90 triangle, our 30, 60, 90 triangle. So I'm going to go ahead and draw it just in case we forgot it, but it is the same one from the do now. Ooh, very small. 30, 60, 90. Ideally, the orientation doesn't matter. What we care about is the length associated to those angles. So the 30 degrees is 1, 60 degrees square root of 3, and 90 is 2. For some students, so they wouldn't have to write both, they actually wrote it out. So they said 30 degrees gives me a length of 1, 60 degrees gives me a square root of 13, and 90 degrees gives me 2. So right here, well, the length that I'm missing is 1, because I already had the square root of 3, I already had the 2. Awesome. So my question is, what theta, right? Because that's what the inverse trig function is asking. What theta gives the length of 1? Gives me the length of 1. So what angle, and we can refer back to our 30, 60, 90 triangle, what length gives me this one right here? Well, we can see that the length opposite is 1. So this theta that I'm looking for is 30 degrees. They want us to have this in radians. So this theta will be pi over 6. So this right here is our solution. Okay. Alrighty. So pretty much this is the question we want to ask. What theta gives us the length of this side, this opposite side? Okay. Keep in mind, if this triangle was in quadrant 2, then this would be a little bit different, which I do have an example about that coming up. Okay. So let's go ahead and apply what we learned. Arcsine of negative 1/2. So we're going to do the same procedure. I want you to look at your notes right here on the right and decide what quadrant will this be restricted to. Okay, so hopefully you're able to see that we're working with sine, and sine is restricted to quadrant 1 and 4. 1 is positive, quadrant 4 is negative. Okay, this right here, it is negative. So therefore, I'm going to go ahead and make my triangle in quadrant 4. Okay. Now from here, I'm going to go ahead and fill in the sides. So according to my Sagatoa, this is going to be the opposite side divided by my hypotenuse. So we can go ahead and do that. So the theta is right here. This is my opposite. My hypotenuse is my longest side, and my adjacent is right on the x-axis. Okay. So go ahead and fill this out. So we have that the opposite length is a 1 and my hypotenuse is a 2. Keep in mind, only one of these can be negative, and the hypotenuse is never negative. So this right here, the negative stays with the -1. Remember, the hypotenuse never negative. Okay, awesome. So we're going to go ahead and do the same question. We should know that this right here is a square root of 3, but honestly, what we want to know is the angle that creates the 1. So what theta gives me a 1, or in this case, a -1. But the idea is the same. The length is 1, just that it's negative. So this is very similar to our last example. Sorry about that. This is still 30 degrees, which we should know is pi over 6, right? If you're unfamiliar how I found this, you can go ahead and multiply the degree by pi over 180. Okay, so 30 times pi over 180 give me pi over 6. And this right here is our solution. Okay. I'm sorry, that is not solution. This is our reference angle. Sorry about that. Our solution, to be honest with you, sorry, I forgot. Our solution is going to be the length, right? The length, let me go ahead and do it purple. The length, the angle that is created from the x-axis all the way over here. Okay, so keep in mind, if I was to have an angle and I go this way, it is a positive angle. If I go clockwise, the same way as a clock, it is a negative angle. So this right here, our actual solution, sorry about that. Our actual solution is pi over 6, but it is negative because I went clockwise, I went downwards. This right here is our solution. Sorry, I almost made a rookie mistake. Awesome. Let's go ahead and try the next one. This one right here messed up my students. But what I want you to know is that in some scenarios, specifically when this number right here is not a ratio. If it's a 0 or a 1, you have to think for the same idea. You're thinking about, okay, I'm working with an arc cosine. So arc cosine is restricted to 1 and 2. However, I'm not seeing any square root 2 over 2s. I'm not seeing 1s. I'm not seeing 1/2. So I'm not seeing square root of 3 over 2s. So I'm actually seeing 1s or 0s. So whenever you see something like this, you're actually thinking to yourself, well, this right here are the only places where I have seen a 1, right? I'm not going to put to 70 because it's not in the restricted domain. I'm sorry, restricted, domain, from -1 to 1, but it's on the restricted range. So what I want you to refer to is these X and Y coordinates. Okay, so these are also in your unit circle, and that's pretty much where we are working in right now. So I want you to think from the center all the way to right, my horizontal changed to 1 and my height was 0. Then from this point right here at 90 degrees, right? This right here is 90 degrees. This became 0 in my horizontal and 1 up. Then 180, 90 more. This is 1 to the left, so -1 and 0 in height. So we are asking ourselves, what theta, what radian gives me 1? Okay. Keep in mind, we're working with cosines. So cosines are cosine x's or y's. When you think about cosines, are they x's or y's? They should have thought about that. This right here is actually when x equals 1. So you're going to go ahead and look at your coordinates, and you're going to see, hey, right here, my x value is 1 when theta is 0. When it is 90, my x value is 0. Ooh, that's what I want. Let's just check the last one to make sure. And my x is -1. So in this case, when theta is 90 degrees, my x value is 1. My x coordinate is 1. Keep in mind we want radians, so 90 degrees is the same thing as saying pi over 2. That is the angle from here to here. Awesome. This is a meme for my students. Hopefully you guys enjoy it. My kids felt like they had just learned sine, cosine, and tangent, and then I'm over here with arcsine, arccosine, and arctangent. RIP. Okay, let's go ahead and try the next one. This right here tends to intimidate a lot of my students because we're working with arctangent. Keep in mind, arctangent is not much different than arcsine, so I'm still restricted to quadrant 1 and quadrant 4, where the positive ones are in quadrant 1 and my negative are in quadrant 4. Okay, now here, what I'm going to go ahead and do is, instead of using this right here for my tangent, which is my TOA, which is my opposite over my adjacent, I'm actually going to think about what I have here, square root of 3 over 3. Hopefully that's something you guys have seen. Whenever you saw this, it originally originated from when you actually had 1 over the square root of 3. You went ahead and rationalized to obtain this proportion. Okay, so you most likely had this, and hopefully you remember it from your notes, 1 over square root of 3, something that happened. But you went ahead and rationalized, and that's how you obtained this ratio. Unfortunately, this ratio is a little bit hard to see, so you have to undo the rationalization. So now we're going to work with this one. So I'm going to do the same thing, arctangent of 1 divided by square root of 3. Now I can go ahead and see that this is a positive ratio, so I'm going to go ahead and make my fraction right over here. And I can see that my opposite is 1. My adjacent is square root of 3, theta. So I'm going to go ahead and look at the angle that creates a 1. And sorry about that. I went ahead and made everything 30 degrees. I did just notice it right now, which is pi over 6 as our solution. Okay. So keep in mind the angle from here to here, is 90 degrees. I'm sorry, not 90 degrees, 30 degrees, which is pi over 6. Okay. I believe I have one last example, and this is going to go ahead and help us for arc cosine, and when it's on, this right here is negative. So let's go ahead and see that arc cosine exists in 1 and 2, where 1 is positive for everything, and then quadrant 2 is negative for cosines. So this right here is negative. So let me go ahead and draw that out real quick. So we have something like so. Sorry about that. Our theta is still in the same place, but cosine is my ka. That is my adjacent side divided by my hypotenuse. So my adjacent side is the negative. Sorry, let's not assume that. Let's say the square root of 3 is my adjacent side, right? This is the adjacent side. My opposite is right here, and my hypotenuse is right here. So my adjacent side is square root of 3, my hypotenuse is 2, and the missing length is 1. Now, I need to stamp this point very clear, guys. There is a negative. However, my hypotenuse cannot be negative, only my adjacent. So this negative is associated with the square root of 3. Okay, now we're going to go ahead and do the same thing. The angle that creates a 1, so the theta, so what theta gives us a length of 1. Gives us a 1. So according to our 30, 60, 90 triangle, my theta is 30 degrees. I'm sorry, guys. I made all of them. Wow, I should not have done that. Okay, so not a worry. This is pi over 6, right? However, is that my answer? Is that the angle created from the x-axis all the way over here? Is that actually no, right? This is a reference angle. This right here is the reference angle. I know that up to here is 180. So what I'm going to go ahead and do is I'm going to go ahead and see, like, okay, I can go ahead and see that this is right here. This is pi over 6, right? 30 degrees. And over here, 180 would be 6 slices of 6. So what I am missing, I'm missing 1 slice. So my answer, my solution would be 5 slices out of the 6, because ideally I am missing 1. Okay. If that is not the way you saw it, you could have seen it in the terms of making sure this was right here. This is 30, this is 180, so this is 150 degrees, right? The remaining side. Okay, and then you could convert it by multiplying by pi over 180. And then just reducing, right? That you could have gotten it like that. I know a lot of students prefer to do this over the radians, but ideally it's not that bad. You have a pi over 6 slice. We know that half a circle will be 6 slices out of 6. So you're just missing 1 slice. So if you're missing 1 slice from 6 pi over 6, ideally you should just have 5 of them. Okay. So our answer is this one right here. Be very careful. A lot of students like to leave it as pi over 6, but unfortunately it is not. Okay, awesome. For homework, I went ahead and gave us 10 questions, very similar to what we just did. Just keep in mind that use your notes, use your domain restrictions, and you should be golden. Other than that, guys, it was a pleasure, and I'll see you guys on the next one. Thank you. Bye-bye.